Welcome you all to the week 10 problem solving session of differential equation for engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of vector geometry and dynamical systems. The last tutorial, or you can say problem solving session, was devoted to D'Alembert's solution for the wave equation of infinite case on the both ends or semi-infinite case from, you can say, one end. So in this problem solving session we mainly focus on the wave equation of finite case, or you can say initial boundary value problems, which will be going to be dealt by method of separation of variables. So let me start with the question number 1. Find the solution of initial boundary value problem. So what will be our given equation? It is the wave equation utt minus c square times uxx equal to 0. Here the case is our x is lies between 0 to L and t is greater than 0, and we have given ux0 is some sine q pi x by L, where x lies between 0 to L. Ut x0 is 0 for the same values of x, and u0t is 0 and ult is also 0 for t greater than equal to 0, t greater than equal to 0. So this is our given wave equation that we want to solve under these conditions. So if you observe, or you can say recall, these are the initial conditions and these are the boundary conditions. Okay, and here I am saying finite. This x is between 0 to L, so length is maximum 0 to L. And if you will observe here, first of the basic thing that I would like to mention here, that this x is not taking 0 and L in the wave equation while we are writing, and while we are writing initial condition, boundary condition, x and t takes the endpoints. Why? Or you can say boundary points. The reason is, in the case of differentiation we cannot guarantee about at the endpoints, or you can say boundary points. That is why we are not writing here, we are not including x equal to 0 and L and t equal to 0. And while writing the conditions, we know that our function is continuous, so we are writing there, we are including x equal to 0 and L and t equal to 0. Okay, so let us start. As I told you, we follow the method of separation of variable. So how we follow that? So let our solution uxt is some function of x of x, t of t, and which is non-zero. Obviously we target to find out non-trivial solution, and one more thing we hint here, this is a non-zero quantity, so we want our solution to be non-zero. We generally focus on non-trivial solution, although the trivial solution may satisfy the wave equation, but it might not satisfy the boundary condition, or you can say initial condition. So we work with this kind of assumption that we are working, we are aiming to get a non-zero solution. So if you will deal with it, so what will be the value of utxt? Ut means you have to partially differentiate this quantity x of x, t of t. So this will be nothing but x of x t dash of t. In the same way, if you will see utt xt, so this will give you x of x t double dash t, and similarly our uxx xt will give us x double dash x t of t. Okay, we know the value of uxx in terms of our this approach. So what we will do, we will put these values in the given PD wave equation. So it will be x of x t double dash of t minus c square x double dash of x t of t equal to 0. So if you will observe here, what you will get, x double dash of x divide x of x t double dash of t divided by t of t. Suppose this is some lambda, say some constant. So from here, if you will try to get that x double dash x minus lambda of x equal to 0 and t double dash of t minus lambda t of t equal to 0, we get these two equations. Now using the boundary point condition for this x of x, the boundary conditions are that are u 0t is 0 equal to ult. So what it will imply, it will become x 0 is 0, which is equal to xl. Okay, so now what we can say, our this system x double dash x x0 is 0, xl is 0. So this is our familiar equation. This is some Sturm-Liouville system, and we know how to solve the Sturm-Liouville system. And from here also we want x of x to be non-zero, and moreover this itself imply that x of x should be non-zero. Simultaneously this should also non-zero, this and this. Okay, for all x and for all p. Okay, so we have to search those eigenvalues for which we may get some eigenfunction, non-zero eigenfunction, or you can say non-trivial solution. So since we are familiar to it, so let us let yourself try this one, then we will discuss it. So if you remember that what we do, we divide these into three cases, that lambda may be 0, positive or negative. So let us start with case number 1. Suppose so lambda is positive. So lambda is positive, that means we consider lambda mu square equal to 0 and mu is greater than 0. Mu less than 0 give the same set of solution that mu greater than 0 will give. So we only consider one case. So if lambda equal to mu square, then our system, or you can say auxiliary equation, will be like this. So this will give us, okay, just a second. So we get our m to be plus minus mu, and from here what we can say, our x of x will be some c1 e to the power mu x plus some c2 e to the power minus mu x. Now we know that our x of 0 is 0, so this will provide us c1 plus c2 to be 0, while x of l equal to 0, this will give us c1 e to the power mu l plus c2 e to the power minus mu l equal to 0. If you write this system in matrix form, you will get 1 1 e to the power mu l e to the power minus mu l. This matrix c1 c2 0 0. This is a kind of system ax equal to 0, or you can say null matrix. This has a unique solution if determinant of A is non-zero, and that unique solution is nothing but, and unique solution is x equal to, you can say, if I will draw directly, this is some vector x equal to 0. Okay, now we just need to check this determinant. So this determinant is 1 1 mu l, so this will be e to the power minus mu l minus e to the power mu l, which will be non-zero for all mu greater than 0. These two can be equal only if and only if mu equal to 0, that is not in the domain. So that means determinant of A is non-zero, therefore C1 will be 0, will be C2, and this will imply our x of x is 0 for all x between 0 to L. Now the second case, lambda equal to 0. What will be x of x in this case? So our characteristic equation will become m square equal to 0. That is, we got the case of repeated roots, and this will give us y, I mean x of x equal to some c1 plus c2x. So I am drawing just c1 c2, so you can easily get that these two are different cases. That is why I am saying x c1 c2, the same notation. So x of 0 is 0. This will imply your c1 to be 0. Next is x of l is 0, then this will imply c2l is 0, which will imply, since l is non-zero, so c2 is 0. Again, from these, what you can say, you can say x of x is 0 for all x between 0 to L. So from here we can say neither lambda greater than 0 nor lambda equal to 0 are eigenvalues of the given sturm Liouville system. Now we are left with the case lambda less than 0. So what we assume? We assume lambda to be minus mu square. Again, mu is some positive quantity, and from here m square minus mu square equal to 0. So this will give us, in fact it will be plus. So this will be plus. This will give us m equal to plus minus iota mu. So our x of x will be some c1 cos mu x plus c2 sin mu x. And since x of 0 is 0, then this will imply c1 to be 0. And next one is x of L is 0, then this will imply c2 sin mu L is 0. Now we want the non-zero solution. So if c2 is non-zero, then obviously sin mu L has to be 0. If sin mu L is 0, that means mu L has to be some n pi. Okay, so mu has to be n pi by L. So we got some mu with respect to which our x of x is some c2 sin n pi Lx. Okay, where c2 is is non-zero and c2 is arbitrary. Okay, so you got your function, or you can say non-zero function. We got our non-zero function that we are searching for in case of this eigenvalue Sturm Liouville system. If I would write it only arbitrary, here n is some natural number, n is some natural number, since we want mu to be positive. So if you will write here, this will be nothing but x and x, because it is depending on the n. If our x and s is this, so if I will write, therefore lambda n minus n pi L for n is any natural number are the set of, because n is varying, so eigen values for SL system and the corresponding eigen function is xn of x c2 sin n pi x by n. Now we know xn of x. Now we can deal with the other case, that is for t double dash t minus, it was lambda c square. So here lambda is minus n pi L by square, which will give us n pi L by c square. T of t is 0. From here you will get t of t is some c3. Let me write first equation, auxiliary equation. In this case auxiliary equation will be m square n pi c by L square, which will be 0, and m will give you plus minus iota n pi c by L. So from this case your t of t will be c3 cos n pi c by L, or in fact since it's a function of t, so there will be t plus C4 sine n pi ct by L, and since it's depending on n, so we write here t and t. Okay, now what will be uxt? Because we have solved this, we have used the boundary condition. Now we have to use initial condition also, but that is for uxt. So what will be some u and xt? Because it is depending on n, so this will be x and x, t and t. So this will be nothing but, you can say, sine n pi x by L into c1 c3, or you can say c2 c3, I think c2 c3. So this will be c2 c3 cos n pi ct by L plus c2 c4 sin n pi ct by L. This is your u and xt. So since we don't know this arbitrary constant that we are aiming to find out, and this whole equation depend on n, so they will also depend on n. Cos an n pi ct by L. So for the time being, let me mention it a and b. Later on I will let you know why I am writing here n, or I am willing to write here n, subscript n. So this is your u and xt. What will be your uxt? Uxt will be n belongs to natural number u and xt by superposition principle. By superposition principle, you have to add all of these. So that means this will be some series n 0 to infinity of this quantity. So what is this quantity? This is like this. Let me write it here. Let us shift it somewhat. So this is our unxt. Now this will be our uxt by superposition principle, and each unxt, that we have put the value of each unxt here. So now we want to use our given initial conditions, that are ux0. We have given it as, let me check it, x0, it is given as sine cube pi x by L. So if you will put these values in this particular series, so this will give you that sine cube pi x and pi x by L into some a is equal to, a will be here, so summation n 0 to infinity, you have to substitute t equal to 0 in this uxt. So if you will substitute this value, so this will give you sine n pi x by L a times, this is only a, because cos 0 is 1, sine 0 is 0. Now this is a term and this is a series. We cannot anyway compare of these things. What we will use? We will use the orthogonal property of sine and cos function. We know that 0 to L sine n pi x by L sine m pi x by L dx is nothing but L by 2 if m equal to n, and 0 if m not equal to n. This is the orthogonal property of these trigonometric functions. Okay, so I will prove it after this question. So let us first focus on this. So from here, if you will do this, so what this will give you, this will give you 0 to L sine q pi n pi x by L. So it was pi x by L only. So pi x by L sine n pi x by L dx, and I am directly writing the case when m equal to n. Otherwise I have to write it in two steps like this: m pi x by L suppose, and n 0 to infinity, a is a constant so it will come outside, and 0 to L sine n pi x by L sine m pi x by L dx. So we know that by orthogonal property, so when only m equal to n, then they will contribute some value, and that value is L by 2. So from here we will get your a to be 0 to L sine q pi x by L sine n pi x by L dx divided by 0 to L sine square n pi x by L dx, and this is L by 2, so this whole quantity will be 2 by L 0 to L sine q pi x by L and sine n pi x by L dx. So if you will observe here, this a is depending on the n. So what we have to do, we should write here a n rather than a. Okay, so I am just replacing a n. In the same way, this bn will also depend on n. So how you will get bn? We have to use the other boundary condition, other initial condition, that is utx0. So before that we should solve this one. We may solve it further. So let me use first utx0 is 0. Okay, so utx0 means differentiation of that equation, given solution, and this series then will differentiate with respect to t, and then put t equal to 0. So this will be sine n pi x by L. Your series is sine n pi x by L, and once you differentiate it with respect to t, partially differentiate it, so it will give you sine function and it will give you cos function, and you will put t equal to 0. This quantity will become 0 and this will be left. So bn, and partially differentiation with respect to t will give us n pi c by L, and cos 0 will be 1. So from here again we have a series and we use the orthogonal property, and by orthogonal property we will get your bn into n pi c by L and 0 to L your sine square n pi x by L dx is equal to 0 to L 0 sine n pi x by L dx. Okay, so this value is 0 and this value is some n pi c by L, and this will give you L by 2. So ultimately this is some non-zero quantity, so this will imply bn is 0 for all n. So only the contribution will be given by our an. So we have to now calculate an exactly, explicitly. What is an? So an is 2 by L 0 to L sine n pi x by L. So sine, we have given sine cube pi x by L. So sine cube, we can write it 3 sine pi x by L minus sine 3 pi x by L divided by 4. Okay, we use the trigonometric property, that is sine 3 theta is nothing but 3 sine theta minus 4 times of sine cube theta. Okay, so this will give us 1 by 2L, 0 to L. There will be two factor sine n pi x by L, and this is some 3 times of sine pi x by L dx. One factor is this, and another factor is 0 to L sine n pi x by L and sine 3 pi x by L, x by L dx. Okay, so again by the orthogonal property, these two values, these two sine functions contribute only if first integral will contribute only when your n is equal to 1, and this integral will contribute only when n equal to 3, and otherwise all these two integral will not contribute anything. So that means if I would write explicitly, if n equal to 1, then this value will give you 1 by 2L, 3 times of what is the value, what will be the value of this integral? This will be L by 2. Now if n equal to 3, so 1 by 2L, 1 by 2L, L by 2. Otherwise these both integral will give you 0 value. Okay, so let me write it minus 0, and this is 0 minus L by 2, and otherwise 1 by 2L, 0 minus 0. So you found out your value of an in terms of some cases, that is 3 by 4 if n equal to 1, minus 1 by 4 if n equal to 3, 0 otherwise. These three value you will get. Now if we will put these three value in our given solution, and what we will get, we will get uxt. It was a series from 0 to infinity, and since a0 and all the a3s, or you can say a0, a2 and all the a4, 5, 6 are 0, there will be left, we will left with the two terms only. So let me first write what was the series. N 0 to infinity sine n pi x by L to an cos n pi ct by L. This was our series. Now since n equal to 0, a naught is 0, so 0 and a1 is 3 by 4 sine, since we are putting n value 1, so this will be pi x by L cos pi ct by L minus 1 by 4, n equal to 3, corresponding to n equal to 3 sine 3 pi x by L. It's a little big expression, so I'm just little rearranging it. So cos 3 pi ct by L, this is our uxt, is the required solution of the given initial boundary value problem. So let me just verify it. This answer is correct. That is 3 by 4. And also let me write the domain of our solution. So this is for 0 x to L and t should be greater than 0. So this is our, you can say, is the required solution of the given initial boundary value problem. So the answer is 3 by 4 sin and pi by x by L pi c t by L minus 1 by x. So it is correct. So let me give you one more question to make you familiar with this these two, how to get apply this method of separation of variable. So before that, let me prove the orthogonal property, or you can say we will prove orthogonal property in the last time, after the last question of the class. Okay, after the class. So let me write the one another question that will make you familiar with this method of separation of variable. So find the solution of the initial boundary value problem, and the initial boundary value problem in this case is given like this: 0 where your x lies between 0 to L, t is some greater than 0, and your initial condition is given as x L minus x is when this x is lies between 0 to L by 2, and when it lies between L by 2 to L, this is some L minus x. Ut x 0 is 0 for all L. U 0 t is 0. U L t, this is boundary condition, and this is initial, above is initial condition. This is your boundary conditions, and these are your initial conditions. So we have to solve this by again method of separation of variable. What you will do, you will again assume u x t to be some x of x, t of t is some non-zero solution. Again you will differentiate and you will get x double dash x minus lambda of x is 0, and t double dash of t minus lambda c square t of t is 0. Now in every case it is need not be the same Sturm-Liouville system that we get in the question number 1. So in this you first judge yourself what will be your corresponding Sturm-Liouville system with respect to this x of x, then what will be the value of t, and find out their eigenfunctions, and by superposition principle you should add them, and then we will try to find out the value of arbitrary constants with the help of initial conditions. So try this one, then we will discuss it. So let us start discuss this one. So if you will use your boundary condition, then you will get to know x of 0 is 0 and x of L is 0. This is the same system that we get in the previous question. So that means it will give the same eigenvalue, same eigenfunction, and the same unxt and uxt. So what we will do from question 1, we can say our uxt is sine n by x by L, and this is some series 0 to infinity, and an cos n by ct by L plus bn sin n by ct by L. So this is your uxt. Now what is the difference here? We have given a different, or you can say piecewise continuous function. So we have given this initial condition. We have to utilize it to calculate the value of an and bn. So if you will observe, first of all, your utx0 is 0. So we will make use of it first, so that we can prove that bn's are 0. So how we can say that? Again, you will get 0 summation and 0 to infinity. You have to partially differentiate with respect to t, and then you have to put t to be 0. So this is n pi x by L. When you will differentiate with respect to t, this will become sine, and sine 0 is 0. So we will not bother about it. We will only take care of this term. So bn n pi c by L cos n pi c t by L. When you will put t 0, this will give you value 1. So you will get this series equal to 0. Now again, by orthogonal property, what you will get, let me just rewrite in the following way. This is, let me write this here, and this quantity here, just to avoid any ambiguity. So when you will apply the orthogonal property, what you will get, bn n pi c by L into the integration n by 2, and this is 0. I'm just doing saying that we will multiply sin m pi x by L on both sides, and we will integrate it, and this will give only this value, and this will imply bn has to be 0 for all n in natural. Okay, now we just need to calculate an. How an can be calculated? So let us just make it a little easy. We should write uxt is some n0 to infinity sine n pi x by L an cos n pi ct by L. So from here we have given ux0 is some x when this x lies between 0 to L by 2, and this is some L minus x when this will lie between L. Now this series n 0 to infinity, when we will put 0, t to be 0, sine n pi x by l, this will be this function, that is x l minus x, or let me write it in this following way, just to is some step. This is, you can say, this is its value when you will put t equal to 0. Now what we will do, we will use the again the orthogonal property. We will multiply both, excuse me, we will multiply both the equation with the sine m pi x by l, then we will integrate both the equation. So, and this integral will give lu l by 2. So let me just rewrite it. So I'm saying multiply both sides with sine m pi x by l and integrate from 0 to l. And and by on multiplying with this, and by orthogonal property, you will get this value an, and with l by 2, when only when m equal to n. So that means this integration will be 0 to l by 2 sine n pi x by l dx plus l by 2 to l minus x sine n pi x l. Okay, so one way is to integrate both the values, both the terms, both the integrals, and then you can put their values here, and then you can conclude your answers. And another smarter way that will be helpful in the other questions also, what we will do, we will do substitution, in the way we substitute l minus x to be any t. So from here your dx will be minus dt, and your x t will be, x will be l minus t. So since x was varying from l by 2 to l, so t will vary from 0 to l by 2. So this change will lead us to the integral 0 to l by 2 t sine, if we will solve it a little, we will get n pi minus n pi t by 2 dt. Okay, this will be your integral. Since here sine n pi, so let me solve it here, just a second. So this will be an, I am just keeping l by 2 here, then this will be 0 to l by 2. So this t is here dummy variable, you can say, and whenever this sign is same as sine pi t by 2, only when n is your odd number. When n is your even number, then this will give you minus value. So that means this x sine n pi x by l dx, this will become 2 times if n is odd, and this will become 0 if n is even. I am claiming this. Why? So if you will do just one more step in this integral, you will get to know that this sine function, if it is in sine quadrant, and if pi minus something, 3 pi minus something, then you will get some positive quantity. When you will get 2 pi minus something, then it will be a negative quantity. So that is why this will give negative sign and positive sign respectively. So from here you will get your En to be 4 by 4 by L x cos n pi x by L divided by n pi by L with the negative sign. Minus minus will become positive, sin n pi x by L n pi by L square 0 to L by 2. So this will be like this. Now you will put the value L by 2 cos n pi at L by 2. This will give you cos n pi by 2. Cos n pi by 2 is 0 plus sin n pi divided by n pi L whole square with negative sign. When you will put 0, it will be 0. This will be also be 0. So this will give you 4L divided by n square pi square sin n pi. Sin n pi is nothing but minus 1 to the power n. So this was already, we are dealing with n equal to odd case. Okay, when n equal to odd. Okay, so in odd case, this should be like this. Okay, sin n pi, we are already saying that n pi is some, you can say n is some odd number, so this has to be divided in further manner. So if n is some, you can say 1 3 5, we are saying that if n is 1, then we can say that I think there is some ambiguity in writing, I think so. So this is when you will put L by 2, so this will be sin n pi by 2. Okay, yeah. So when your n is 1, then it will be sin pi by 2, that is 1. 3 pi by 2, then it is minus 1. So when you will talk about 5 pi by 2, then again it is 1. Then 7 pi by 2, then it is minus 1. That is why we are dividing for n minus 1 by 2. Or for sake of simplicity, you may write a 2k plus 1 as 4l divided by pi square 2k plus 1 square minus 1 to the power k, where k can be any natural number. What I have done, I have put n equal to 2k plus 1 in this one, question number 1. Then you will get this thing. Okay, you got the value of ak, you know your the value of vn. Now what will be your series? So uxt can be written as when you will wrote in terms of odd things, that's n is an odd integer, then this will be 4 times minus 1 n minus 1 by 2 l divided by n square pi square sin n pi x by l cos n pi c e by l. Or the other way is to write in uxt is, since I have put n equal to 2k plus 1, that means this series will start from 0 to infinity 4 times minus 1 to the power k l pi square 2k plus 1 square sine 2k plus 1 pi x by L cosine 2k plus 1 pi ct by L. This will be valid when your x lies between 0 to L and your t lies between 0. Is the given, or you can say given, not given, is the required solution of the given initial boundary value problem. So this is your solution of the given initial boundary value problem. Okay, so let me just re-verify it quickly. So that is correct. So till now we have learned on method of separation of variable of two questions in which both the eigenfunctions was sin m and pi x by L. Now what if we have changed boundary condition in some sense? What is will be our corresponding Sturm-Liouville system, and what will be the your solution of the given PD or initial boundary value problem? So this will be included in this question number 3. So find the solution of the initial boundary value problem, which is UTT minus 9 times of UXX. Here we have fixed the constant, and also we have fixed the value of L, that is 20, and t is greater than 0, and our initial condition is given as ux0 is x, 20 minus x, and our x lies between this 0 to 20, and when I have wrote the second case first, so it will be 0 to 10 and 10 to 20. Next is utx0 is some quantity here, that is x into 20 minus x, 0 to x less than 20, and again u0t is 0 and u20 comma t, where t is greater than equal to 0. Now this is also the same case like the earlier cases, but the difference is here we have this velocity is non-zero here. Okay, so otherwise this boundary condition is same as the earlier. So what we can say that let uxt is some x of x, some t of t, and this is some non-zero solution, and from here your x double dash x minus lambda x of x is 0, x of 0 is 0, x of L is 0, same Sturm-Liouville system, and your t double dash t minus lambda t of t lambda c square t of t is 0. Okay, so from here you will get same x and x, same t and t, and your uxt will come out to be like this series summation n 0 to infinity sine n pi x by L, and an cos n pi ct by L plus vn sine n pi ct by L. So this is our targeted series where we have to find out this arbitrary constant an and bn that are depending on mainly their n. So how can we do this? So we have to use the initial conditions. So first initial condition is u x0 is 0, the given function. So before that let me just make a change. Here L is given as 20 and C is given as 3. So let us put those values here. So n pi x by 20, and this will be 3n pi divided by 20, and this will also be 3n pi divided by 20. Okay, so we have given what will be ux0 from this series. This will be n 0 to infinity sine n pi x by 20 into this an. Okay, and this series is equal to that function that we have given here. Okay, when you will multiply, or you can say, let me write it here. So this is your x and 20 minus x when this x lies between 0 to 10, and when x lies between 10 to 20. So what you will do, you will again use the orthogonal property, and that orthogonal property will give you L by 2, 0 to L by 2 x sine n pi x by L dx plus L by 2 12 20 minus x sine n pi x by 20 dx. So we have given L, so what we may write it here 10 10 and this is 20. So if you will observe here, this an is nothing but like the previous case. So these two values are equal when n is odd, and these two values are addition of these two will be 0 when n will be even. Okay, so let me just quickly write this. So this is n is odd, and when n is even. It was positive sign in the previous case also. Yeah, it was a positive sign. So this will give you 20 by 2. This will be 1 by 10, and 2 times will come from here. So 1 by 5, 0 to 10 x sine n pi x by 20 dx, and this is when if n is odd, 0 if n is even. Now what will be the value of this x sine n pi x by 20? Again from the previous also you can see, or otherwise you can directly calculate cos n pi x by 20 n pi by 20 sine n pi x by 20 n pi by 20 whole square, 0 to 10. So from 0 to 10 this will be 0, and this will be some your sine n pi by 2 divided by n pi by 20 square with negative sign, 0 minus 0. So this will be your value of the integral, and from here you can say your an will be when you will put it here 400. So divide by 80 minus 1 to the power n minus 1 by 2 divide by n square pi square, where your n is any odd number, and 0 where n is even. Okay, or you may write it a 2k plus 1, or 80 minus 1 to the power k pi square 2k plus 1 whole square, where k can be any natural number. Okay, till now we have find out the value of an. Now we have to find out the value of bn using the condition or initial condition x into 20 minus x. Okay, again when you will differentiate with respect to t and put x equal to 0, then you will get the series n0 to infinity bn sine n pi x by 20, and here n pi ct, that is 3n pi by 20 into 3n pi by 20 is equal to this x 20 minus x. This will be your value. So from here, so again you will integrate, multiply with sin m pi x by 20 and integrate from 0 to L. Then you will get the value here bn 3n pi by 20. This integration will give us n L by 2, that is 20 by 2, which will be equal to 0 to 20 x 20 minus x sine n pi x by 20 dx. So from here your bn will be 2 3n pi 20x minus x square, and with negative sign cos of n pi x by 20 divided by n pi by 20 minus minus plus 20 minus 2x sine n pi x by 20 divided by n pi by 20 whole square, and with negative sign, and negative negative will become positive, so this will be 2, and but cos will give again a negative contribution, n pi x by 20 divided by n pi by 20 whole cube 0 to 20. So from here your bn will be 2 divided by 3 and pi. So when you will substitute 20, this will give you n pi by cos n pi, and just let me check. At 20 this quantity will be 0, and at 20 this will be sine n pi, so this will contribute in some sense. Again when you will substitute 20, then this quantity will contribute somewhat, and what will be that, we have to see that. So try, then we will discuss. So this will again become 0, sin n pi is 0, so this will be 0 minus, this will give you 220 cube divided by n cube pi cube cos n pi. Cos n pi means minus 1 to the power n. Okay, with negative sign, when you will put 0, this will be 0 0, and this will be minus 2 into 20 cube divided by n cube pi cube. So this is your bn. Your bn, if you will, I will a little solve it. This will give us with negative sign 420 cube divided by 3 n pi power 4 minus 1 to the power n minus 1. Okay, so again we are dividing the case for an odd and an even. When your n will be odd, then this will quantity will become minus 2, this quantity will contribute minus 2, so this will be 8 times 20 cube divided by 3 n to the power 4 pi to the power 4 if n is odd, and 0 if n is even. So either we may write like this, or we may put n equal to 2k plus 1. When you will combine it, your uxt will be a series of odd terms, and this will be like this: odd terms sine n pi x by 20. Your en was 80 minus 1 n minus 1 by 2 divided by n square pi square cos 3 n pi 3 by 20 plus 8 times. So 8 times 20 cube can be solvable, so it will be 64,000 divided by 3 n to the power 4 pi to the power 4 sine 3 n pi 3 by 20. Okay, either this or uxt can be written as full series 0 to infinity sine 2k plus 1 pi x by 20. This will be 80 minus 1 to the power k divided by pi square 2k plus 1 square cos 3 into 2k plus 1 pi t divided by 20 with addition of term 64,000 divided by 3 pi to the power 4 2k plus 1 power 4 sine 3 2k plus 1 pi t divided by 20, and your x here will lie between 0 to 20, and t will be greater than 0 is the required solution of the given intermediate, oh sorry, initial boundary value problem. So either you may choose the first one or you may choose the second one. Okay, both answers are correct. Now till now here we have just make a change in the initial condition. In the next problem we are going to make some change in the Sturm-Liouville system that we are going to get, and that with the behalf of that we are going to find out the arbitrary constant. So it is as follows: find the solution of the initial boundary value problem utt minus uxx is 0 where x lies between 0 to 20. Here pi t is greater than 0, and here ux0 is 0 0 to x in between pi. Your ut x0 is 1 plus cos cube x 0 to x between pi. ux0t is 0, ux pi t is also 0, t greater than 0. We have transformed this, replace this boundary condition. We have also changed this initial condition by putting it equal to 0. So this is your given initial boundary value problem. So in this initial boundary value problem, so what you will do, again you will start with uxt equal to a non-trivial solution t of x of x, t of t, and your corresponding Sturm-Liouville system will be like this: x dash 0 is 0, x dash l is 0, and your t double dash t minus lambda c square, yes, that is 9 lambda t of t is 0. In the same scenario, the previous case also, here it would be 9 lambda, since c is fixed, so that will be 9 lambda. So you have to solve this Sturm-Liouville system first to see what is the value of x of x, the eigenvalue of eigenfunction, and the value of eigenvalues, also the eigenvalues. So then you will put substitute in this t of t, then you will get your uxt, and then you will find out the arbitrary constant with the help of initial condition. So first of all, you should try this at your own, then I will discuss it. So to solve this Sturm-Liouville system, we have to again divide the cases in this manner. First is lambda greater than 0, then we have to assume is some mu square, and mu is greater than 0. So your x of x will be, so from here your auxiliary equation will be mu square 0, and this will be m equal to plus minus mu. This will be c1 e to the power mu x, c2 e to the power minus mu x, and since x dash of 0 is 0, that means C1 mu minus C2 mu is 0. That means C1 is equal to C2 since mu is positive. X dash of L, that is X dash of pi here. So X dash of pi is 0. So this will imply C1 e to the power mu pi with multiplication of this mu, since we want to differentiate it first, then this will be C2, and C2 is nothing but C1 mu e to the power minus mu is 0. From here we will get to know that C1 mu e to the power mu pi minus e to the power minus mu pi is 0, and this quantity is non-zero. That means this will imply C1 is 0, and C1 is 0, then this will imply C2 is 0, therefore X is 0 in this case. So lambda greater than 0 cannot be the eigenvalue of the following Sturm-Liouville system, and lambda equal to 0, that means X double dash of X is 0. That means auxiliary equation is m square 0. That means m must be 0 comma 0, and x of x must be of the form c1 plus c2x. From here we know that x dash of 0 is 0. That means c2 is 0. Since c2 is 0, then obviously x dash of pi will also be 0. Therefore x of x will be equal to c1, or you can say x of x is equal to 1. I have fixed c1 as 1. Okay, so that means lambda equal to 0 is an eigen value of the SL system with its corresponding eigen vector x of x equal to 1. Okay, next is lambda less than 0. M square plus mu square will be 0. I am assuming lambda to be some minus mu square, where mu is positive one. So this will give you m equal to plus minus iota mu. So from here you will get your x of x to be c1 cos of mu x plus c2 sine of mu x. So since x dash 0 is 0, then this will imply cos will become sine, and sine 0 is 0, so we don't need to worry about it. c2 mu will be 0 from here, and this will be this will imply c2 has to be 0. Next is x dash pi has to be 0. That means minus c1 mu sine mu pi has to be 0, and this will imply since we want to find out non-trivial solution, so what we will say, if c1 is non-zero and we know that mu is greater than 0, then sine mu pi has to be 0, and mu has to be some n, where n is any natural number, since mu has to be positive. So since we got mu equal to some n, so from here this is your eigen values, and eigen function will be, so lambda n will be minus n square are eigen values, and eigen function will be from here eigenfunction will be, since c1 is arbitrary, so x of x is some c1 cos n x, where n is any natural number. Okay, so from here you got x and x or x naught x. In fact, if I would say, it will be x naught x, since it's corresponding to lambda equal to 0. Here let it be, then here not x. Okay, so let me write t double dash t. When lambda is 0, then t double dash t minus lambda is 0, so this will be 0, and this will give you t of t equal to some a naught plus b naught t. Since we are dealing with you can say lambda equal to 0 case, so I am writing like this. When lambda equal to minus n square, then your t double dash t minus will become plus 9n square, t of t will be 0, and from here your t and t will give you m square plus 3n square equal to 0, that is m equal to plus minus 3 iota n. Okay, so this will give you c3 cos 3n t. So I think here is some error, or let me just write it. So this is correct, this is correct. So cnt plus c4 sin 3nt. Okay, from here you got your tnt for both the cases. Now we have to combine uxt. So here uxt, this series will start from e naught t plus n 1 to infinity x and x t and t. I am writing this separately because it is a linear function, linear kind of function. Then your uxt will be a naught plus b naught t plus n 1 to infinity. I'll combine this c1 and c3 as an, and c1 and c4 as bn, as like earlier cases. This will be cos nx an cos tnt plus bn sin tnt. Okay, now the given condition, first one is, initial condition is ux0 is 0. So this will imply a naught plus n 1 to infinity an cos nx has to be 0. So again, it's the left hand side is a series, this is a number, you cannot compare it. So we'll use the orthogonal property, multiply on multiplying with cos mx on multiplying cos mx on both sides, and by using orthogonal property of sine and cosine function, we get a naught 0 to pi both sides, and integrating from 0 to pi. Okay, 0 to pi cos nx. Why I'm writing nx? Because this series only give non-zero value when m equal to n. So this will be a n 0 to pi cos square nx dx is 0. And this is some sin nx, sin n pi is 0. So let me just solve it. Sin nx divided by n 0 to pi plus a n, and this is nothing but pi by 2. Okay, this is 0. From here this quantity will become 0, and from here your en is 0 for all n from natural number, and from this one equation by 1 you can say a naught will be also be 0. Now what will be the contribution left? Contribution left of Pn only. So for that we have to use utx0. It has been given as 1 plus cos qx. Okay, so when you will put utx as 0, then you will get, have to differentiate it first, that is b naught plus summation n1 to infinity 3 times of n bn cos nx is equal to 1 plus cos qx. Again we use the orthogonal property, and we will get from here that integration b naught 0 to pi cos nx dx plus integration 0 to pi dn cos. So let me write it constant outside. This is bn, or you can say 3 times of bn, 3n bn cos square nx dx is equal to 0 to pi 1 plus, again I will use the cos identity of cos functions, that is 3 cos x plus cos dx divided by 4 cos nx dx. Okay, so from here this quantity is nothing but 0, as like the earlier case. This quantity will be 3n pi by 2 bn, and from here first integral, that is cos nx, that will be 0, 0 to pi cos nx, this will be 0 plus 3 by 4 0 to pi cos x cos nx dx, and plus the third term is 1 by 4 0 to pi cos 3x cos nx. So by the orthogonal property, from here you will get 3n pi by 2 is equal to, when n equal to 1, this quantity will give you pi by 2 value. So this will become 3 pi by 8 plus 0. Okay, when n equal to 3, this quantity will become 0, this will be pi by 8, and otherwise this will be 0. So from here you can conclude that this is nothing but 2, that is 1 by, if you just include it, 1 by 4. um, since n equal to 1, okay, we have to keep in mind when n equal to 1, I am talking about these cases. So when n equal to 1, this will be 3 pi by 2, and this will be uh, pi by 1 by 4, and when n equal to 3, then this will become 1 by 36. Okay, 0 otherwise. Okay, so for simplicity, no more confusion, you can do 2 by 3 n pi. You may write it 2 by 3 n pi. So you may write it 2 by 3 pi, 2 by 9 pi. Okay. From here you will get b1 as 1 by 4 and b3 as 1 by 36, and all other bn's are 0 from here. If all other bn's are 0, so what will be your uxt? So uxt will be summation. It was n0 to infinity, since a n are 0, cos nx. So let me just like this. Okay, so we missed one thing. We have to calculate b naught also. What will be your b naught? This is the case if n is 2 and n is greater than equal to 4. What will be your b naught? You have calculated this one, but you should take care of b naught also. So how we can take care of b naught? B naught is an arbitrary constant. So what we can say, because so let me just first write uxt, then maybe you will get to know. Uxt will be b naught plus summation n from 1 to infinity bn cos nx sine 3n t it was. So from here, since it is like this, and your uxt will be b naught t plus b1 is 1 by 4, so this will be cos nx sine 3n t divided by 4 plus cos nx sine 3n t. So this is the case when n is equal to 1. This will be 3n cos x and 3t. So we should keep this in our mind, that we have substitute the value of n here in this particular case. In the same way, when we will substitute the value of n 3, then it is like following: cos 3x sine 9t divided by 36. Okay, so here your b naught is still not calculated. So for b naught, what you have to do, you have to substitute these values in the given equation. So it was like this was your equation. So what you will do, since your series has become only 3 terms, that is 1 by 4, 1 by 36, and others are 0. So because of that, this will become 1 by 4 cos x plus 1 by 36 cos 3x. This has to be equal to, what was that, 3n times we also multiplying it, so it will be 3 by 4 and 1 by 4. I think when there might be some technical issue. Okay, so there was some technical issue, so I'll write it the other part again. So we reach to the equation when your p naught is p naught plus, it was 3 by 4 cos x plus 1 by 4 cos 3x equal to 1 plus 3 by 4 cos x plus 1 by 4 cos 3x. When you will compare these quantities, you will get your b naught to be 1, and b naught is 1. your uxt is completely, it can be written as sine x cos dt divided by 4. Sorry, it was cos x and this is sine plus cos 3x sine 90 divided by 6, and this is when 0 to x less than 5 and t is greater than 0 is the required solution of the given initial boundary value problem. Okay, so this is your different case of, you can say, Sturm-Liouville problem or totally intermediate value problem. Now in the last question what we will do, we will take some another boundary point condition, so that will lead us to different Sturm-Liouville problem. So it is like this: find the solution of the initial boundary value problem, and this is given as utt minus 9xx equal to 0, 0 to x, y is greater than 0, ux 0 is 0. Next is ut x0 is same, we are writing it same, so that means we don't need to calculate the constants in this scenario. You just need to see what is our eigen function, because we are changing only boundary condition ut0 is equal to x by t, where t is any zero quantity. So from here, let me just first quickly write what will be the Sturm-Liouville system in this case. So let uxt is any non-trivial solution, that is x of x, t of t, this is non-zero solution. Okay, so from here you will get x double dash x minus lambda x of x has to be 0, x of 0 is 0, x dash of pi is 0, and t double dash of t minus lambda c square, that is 9 lambda t of t is 0. So from here, this is our a new Sturm-Liouville system. What we will do, we will again deal with the case lambda greater than 0. That means lambda must be some mu square, that means m square minus mu square equal to 0 will be the auxiliary equation, and m equal to plus minus will be its solution, and our x of x will be c1 e to the power mu x plus c2 e to the power minus mu x. From here, x of 0 is 0, this will imply c1 equal to minus c2, or you can say c2 equal to minus c1. Okay, next is to derivate it and put pi. So this will give us c1 mu e to the power mu pi with negative sign, which will become positive sign because c2 is minus c1, mu e to the power minus mu pi, this has to be 0. That means c1 mu e to the power mu pi plus e to the power minus mu pi, this is 0, and this quantity is a non-zero quantity, this will imply c1 has to be 0. So whole soul, we can say x will be 0, okay, by 1. Okay, so again lambda equal to 0, is the case now. When lambda equal to 0, our m square will be, auxiliary equation will be m square equal to 0, m is equal to 0, 0. That means x of x is some c1 plus c2x. X of 0 is 0. Will imply c1 is 0. X dash of pi is 0. This will imply c2 is 0. From here again x is 0. So that means lambda equal, neither lambda equal to 0 nor lambda greater than 0 contribute in as an eigenvalue and eigenfunction. Okay, now we will left with lambda less than 0. That means lambda can be minus mu square and mu can be any positive quantity. So from here m square plus mu square has to be 0 and m has to be plus minus iota mu, and your x of x will be from here, your x of x will be c1 cos mu x plus c2 sin mu x, and x of 0 is 0. This will imply c1 has to be 0, and since x dash of pi is 0, then this will imply c2 mu cos mu pi has to be 0, and if c2 is non-zero, then cos mu pi is 0 and mu has to be some 2n plus 1 by 2, or in fact 2n minus 1 by 2, where n can be any natural number. Okay, so this is your eigenvalue. So therefore lambda n equal to minus 2n minus 2 whole square, where n is natural number, are eigenvalues, and x and x is equal to since our c2 is a non-zero, that means it will be some c2 sine 2n minus 1 x by 2 are eigenvalues. Okay, so you got your eigenvalues and eigenfunctions here. From here you will put these values in t double dash t plus 2n minus 1 by 2 whole square divided by 4 into 9, t of t is 0. From here your t of t will come out to be c3 cos 3 into 2n minus 1 t divided by 2 plus c4 sin 2n minus 1 t divided by, okay. So from here your uxt come out to be n 1 to infinity. Since it was a sine function, so it will be sine 2n minus 1 x by 2 an cos 3 2n minus 1 t by 2, and a little rearrangement first, plus bn sine 3 2n minus 1 t by. Now just we need to find out this constant value, and for that we will use our initial condition. What is our initial condition? The first one is ux0 is 0. ux0 is 0. Okay, so if you will observe from the previous case, so this will be summation n 1 to infinity sine 2n minus 1 x by 2, and this will be some a n is 0. From here, this is your quantity, that this is 0. From here you can conclude that an has to be 0 for all x. An has to be 0 for all x, and for all n. Now the second case is ut um, x 0 is 1 plus cos cube x. Okay, so how we can deal with it? There's just a second, some technical errors are. So utx0 is 1 plus cos cube x. So from here you will get summation n 1 to infinity bn sine 3 2n minus 1 e by 2. This will be 1 plus cos cube x. Again you will multiply sine 2m minus 1 by 2 t by 2. Okay, here it will be 2n minus 1 x by 2, and there will be 3 times of will be 3 times of 2n minus 1 by. Okay, so from here what you will get, and you will multiply with the sine 2m minus 1 x by 2, and you will apply the again the orthogonal property. Then you will get the value of this bn as bn 3 2n minus 1 by. I hope my screen is visible. Okay, there is some error, I think. Let me just rejoin it. So I hope the screen is visible now. So okay, from here what we are talking about again the orthogonal property, using the orthogonal property of this sin m and 2m minus 1 x by 2. So this will give us value pi by 2, and this will be 1 plus you can say integration 0 to pi 1 plus 3 by 4 cos x plus cos 3x by 4 sine 2n minus 1 by x by 2 dx. Here it is cos x, it is some 2n minus 1 by x by 2. So how we can use here the orthogonal property that we have to take care 2n minus 1 pi. This should look like in this format so that we can compare, because if you will compare the orthogonal property 2n minus 1 x by 2, the other one should be cos 2m minus 1 x by 2, like this one. Okay, so to compare this, these two look like in the same format. So can we write x in terms of some 2n minus 1 type of thing? So if we will try to write it, so 2n minus 1 by 2, you can say this should be 1. So n should be, you can say 2n is equal to 3. So n is equal to 3 by 2. So this will not be the correct format for this particular one. So we will just calculate its value like normal integration. So this will be minus cos 2n minus 1 x by 2, 2n minus 1 by 2. This is our first part of integration. This is our whole bracket and this is just this one. Okay, and from here you will integrate it. This will be 0 to pi 3 by 8 cos, when you will add them, this will be 2n plus 1 x by 2 with positive sign, cos 2n minus 3 x by 2 dx. One quantity is this, and what will be the other quantity? The other part will be can be written as so the other part will be 0 to pi 1 by 8 cos, so this is 3x, this will be 2n minus 1 plus 3, so this will be 2n plus 5 x by 2 should be like this. Then this will be, here will be, since I am taking sine A plus sine B, I am taking like this. This will be sine, sine, this will also be sine plus sine 2n minus 7 x by 2. So this will be our whole integration, and this will come out to be by 3 n minus 1 5. And if you will calculate this value, so the first one will give you cos 2n minus 1 pi by 2. Then this 2n minus 1 pi by 2 will give you, uh, since it's a odd multiple, so 2n minus 1 pi by 2. We just check it. So this will be 0 minus minus will become positive when it is 0 to n. Okay, next is plus, or you can say this will give you minus because sine is, integration of sine is cos. This will be some cos 2n plus 1 x by 2 divided by 2n plus 1 by 2 with positive sign because I have taken outside already negative sign, x by 2 2n minus 3 by 2 0 to pi. Next one will be, again I can take 1 by 8 cos 2n plus 5 by 2 divided by 2n plus 5 by 2 plus sine cos 2n minus 7 x by 2 divided by 2n minus 1 7 by 2 0 to 5. So this is our whole integration, and again at pi these values are 0. You would left with the case when x is 0, 2n minus 1 pi. So this will give you value 2 by 2n minus 1, and this will be plus 3 by 4 2n plus 1 plus 3 by 4 2n minus 3 plus 1 by 4 2n plus 5 plus 1 by 4 2n minus 7. These are your values of Bn, and what will be your uxt? Your uxt can be written as 4 by 3 minus 1 pi. Okay, sorry. This is your value of Bn. Uxt will be summation n1 to infinity Bn sine 2n minus 1 x by 2 sine 3 into 2n minus 1 by 2, and Bn is given like this, and this is your go to x to L, L here is here 5. The above also we should write it here 5. 5 is the given square solution of the given shell boundary value problem. So we are left with that orthogonal property that I told you. I'll discuss that 0 to L sine nx sine mx dx is L by 2 n equal to m and 0 n not equal to m. So you just need to apply sine a plus sine b property, and then you will get to know why these integrals are giving this value. You can try, then I'll let you know. So it is like somewhat easy. So if you n is not equal to m, then this integral 0 to L sine nx sine mx dx, this will give you 1 by 2 0 to L cos n minus m x minus n plus m x dx, 1 by 2 sine n minus m x divided by n minus m. So there is one thing, it will be 0 to pi if I will integrate. If I have to take in terms of L, then it will be n pi x by L. This will be sine n plus m x divided by n plus m 0 to pi. So this will give you 0 value, because sine n pi is 0, sine 0 is 0, and when n equal to m, well, sine n square x dx, this will be 0 to L 1 plus cos 2nx divided by 2 dx, and this will give you x by 2 plus sine 4nx divided by 4n 0 to pi. I again missed L is not here, pi. This will be pi by. Okay. So in the same way, you can judge sine and cos and sine, different possibilities, or you can say sine n pi x by L and sine m pi x by L. Their integration from 0 to L will be n by 2. So that's all from today's class. Let us meet in the next tutorial session that will be on next Tuesday. Thank you.